Hey guys, Taylor here. So today I was building gears for a drone that I'm working on, and it was kind of hard to get all the information on how to build gears and kind of understand them. So basically the gears that I built were Spur gears, and they just look like this. So it's as simple as that. So what I kind of want to do is talk about some of the gear principles, not so much about the gear sizes and how they change torque and velocity, but more just about building the teeth of the gears. Because that's kind of, to me anyways, was the non-intuitive part. And then so yeah, I just want to touch on that. So I'll kind of explain the basic concepts you need to understand, and then I'll jump to Inventor and actually show how to do it in Inventor. I think if you understand the basic concepts, that's the most important piece. So there's a few things we have to understand when we're talking about spur gears. And so most gears, you kind of have, I think, intuition gives you a pretty good idea of how they'll work together. You know, if you have a gear that has a certain diameter and a gear with twice that diameter, and there's an axle in the middle of each gear, as the smaller gear spins, it will rotate the larger gear slower around the outside, and the torque will be greater on the inside. So if this is, you know, the diameter of this circle is 1 and this is 2, then basically the torque will increase, will double. That relationship is very simple. So that's kind of the uninteresting bit about gears. So the thing that I found non-obvious was it would be great if we could just design gears as though they were circles, and you know, put them together, and if you want to get twice as much torque, you just make one circle and you put it next to another one, and they work great. But you could even envision it as a circle, and maybe you put a rubber band on the circle and they touch each other and one spins, and if that works for your situation, then that'd be awesome. But generally what you need is these teeth on the gear, and so the teeth you know, will just act like this. And this wasn't obvious for me. I always thought teeth on gears were just square, but they're actually not square. They're actually kind of curved at the top, and I'm going to talk about that curve and how to make it. But so when designing a gear, you can really think about just two things. You just need to think about the gear, how many gears are on each tooth, and this gear has 18 teeth, and then the diameter. This gear happens to be 40 centimeters. And so once you know those two things, you can design your first tooth. And generally when you're designing teeth, you want to think about design the smaller tooth first and then the bigger one. And here's why. It's because when you're designing a tooth, when you're designing a gear, you need to make sure that the ratio of between the diameter and the gear size is equal on any tooth. So what I mean on any gear rather. So what I mean by that is if you have a gear that has the diameter of 1 and it has 18 teeth, and you have a gear with the diameter of 2, then you're going to need twice that many teeth. So on this one, you're going to need 36 teeth. So the way to think about it generally is you know, think about your first gear, what you're going to do there, and then just double it, and you'll also double the teeth amount. And there's actually a word for that ratio, and it's called, in gearing, I'm not sure if gearing is a real thing, but it's called the module, and that's actually it's the diameter. All it is the diameter over the number of teeth. So it's really simple, but it's an important parameter because what we'll talk about. We use this a lot when we use it when we're designing the teeth of our gear. So let me just talk about a few concepts, and I'll start with this stuff is almost all really simple. There's one bit that's a little confusing, so I'm going to start with the simple stuff. So let's say when you have a gear, so we're going to have, this is just, you know, a gear, and it will have teeth on it like this. I hope that's okay. So just a few things. So real quick, so when you're actually thinking about designing the gear, and I said before we're going to design a 40 millimeter gear, what we actually start with is this this circle called the pitch circle, and this is the actual circle that's going to be 40 centimeters. So you can envision that as being 40 centimeters. What it is, it's whatever radius you want your gear to operate at, basically, is the way to think about it. It's actually a virtual thing. There's no, we only use it for design purposes. It is the radius at which gears will generate torque. So it's the radius that you want to use for your ratios. In other words, if you have 40 millimeter diameter gear that's driving another one, you're thinking about it in terms of pitch circle. So you really are thinking about it as, if you have a 40 millimeter one gear, it could drive an 80 millimeter diameter gear and generate twice the torque, for example. But so this is our pitch diameter. We'll call it the pitch circle. And my marker's not being great. So, and in our example that we're going to do, it's going to be 40 millimeters. And then above it, we have kind of where the teeth end, right here, is called the addendum. We'll call it the addendum circle. I think that addendum circle. And in order to figure out this length when we're designing, the equation's really easy. Remember when I talked about the module before? The module was just the the diameter over the number of teeth. And so the diameter we're going to say is 40, and we're just going to make it really simple, and we're going to say we're going to have 20 teeth on this particular thing. So on this particular gear, the module is going to equal 40 over 20, which is 2. So the module's 2. And so this is really simple. The addendum circle, the distance between the pitch circle and the addendum circle, is just the module. So here, that distance is equal to the module. So it just equals 2. Simple as that. And then we have this other circle to think about, kind of the inner circle here, and this is called the dedendum. And the distance here between the pitch circle and the dedendum circle, this is a little less obvious, but it's still pretty easy. It's just the module times 1.25. So it's a little bit bigger than the addendum. The distance is a little bit bigger than the addendum. So you can just draw those, when you're designing it, that's kind of where you're starting, is drawing those two circles. And so, the dedendum circle and the addendum circle. Now there's another concept, and here's where things get a little bit tricky, so pay attention closely. So, I'll erase this, but remember this. When we're designing it, you'll need to know these things. Before I move on, one more simple concept. So the distance between the teeth, so when we're measuring the tooth width, we think about it right here. You can see the tooth is, because it's kind of curved like this, it's different widths, right? So when we think about the tooth width, we actually should think about it like this width. And that width is where the pitch circle crosses the tooth. So it's here to here. And it's the same as basically the non-tooth. So this distance is the same as this distance, right? And so if we have 20 teeth going around, let's say we have, well, anyways, yeah, that's all you need to know for now. It's pretty simple. So again, the tooth width here is the same as the non-tooth width, because it'll be the same as the tooth width of the other gear that's coming in. So all pretty simple stuff as of now. And so here's where it gets a little bit complicated. It's not very complicated, but it's really the only thing that, if you're designing it, in my opinion, well, some of this stuff isn't intuitive, but it's the only thing that you might have to just think about for a second. So when we have gears, there's always two gears coming together. So I'm gonna, let's say this is the top, this is the drive gear, and this is the gear being driven. It doesn't really matter from a design perspective which one is which. So again, they'll have teeth. I have the worst teeth, but teeth. They're coming in here, and these teeth are actually curved. So a couple things. So the teeth aren't square. If you're like messing around looking at some gears and stuff, you'll see that they kind of go like, and I'll try to get one tooth that's good. They'll be a little bit flat on the bottom, then they'll have this curve, and it looks kind of like a circle, and it looks a little bit like a circle up at the top. But then you'll also notice on some of them that it'll either be flat and it'll start to circle at some point. It'll kind of be flat here, and then it'll start to circle, or it'll be kind of like curved this way. But generally, it can just be flat, and then it'll start to circle. But anyways, so let me talk about how to make this circle, because it's not just a circle, and you might be thinking about how to make it. But what that's actually called is an involute curve. So this thing right here is an involute curve. So an involute curve is, if you think about a circle, think about a piece of tape, for example, and pretend this is your gear, and pretend we're unwrapping this piece of tape on our gear, and we're just drawing a line. And here is our actual circle. And so if this is the diameter of our circle, whatever this piece of duct tape is, this is the involute curve of that circle, if that makes sense. And so it kind of has a cool property or whatever. But so the corner of this is actually an involute curve. And it's an involute curve of a particular circle, but that particular circle is not our dedendum circle, and it's not even our pitch circle, which runs through the middle of the teeth, and it's not the addendum circle. So it's none of those circles. So what is that circle? And this is the only complicated part, so try to follow along. So we call that circle the base circle. The circle that we use to draw the involute curve is called our base circle. And how we find it, I'll just tell you how we get it. Well, before I tell you how we figure out the size of the base circle, which is basically going to be a circle that looks like this. It'll be a little bit larger than the dedendum circle, but it'll be smaller than the pitch circle. And definitely smaller than the addendum circle, which is on the outside. So when gears, so the base circle can actually be different sizes. Is the answer to that? So, it can be different sizes, but as we change its size, it'll vary what we call I guess we could call it the pressure angle. And the pressure angle is how the gear that generates force, how gear 1 puts force on gear 2. And so intuitively, you might just think that the force is always in this direction, kind of perfectly, I guess, perpendicular, or there's another word for that I'm blanking on, but perfectly straight. But it ends up, as these teeth push against each other, the force is not perfectly straight. It goes at a particular angle, and that angle is, honestly, I can't remember what it's called, but it has a name. But we can call it we'll call it the pressure angle. I think that might be it. And so you can choose the pressure angle you want. Is the bottom line. And the pressure angle we want is 20 degrees. It's kind of the de facto pressure angle that when people are making gears use. It comes from engineers doing trial and error. But so if we're going to use engineers have tried other angles like 14.5, 25 degrees. Apparently 20 degrees is the magic number for applying force on one gear to another. It beats me exactly why, but anyways, to get the diameter of the base circle, the equation is really simple. So let me write it out. The base circle diameter is simply equals the cosine of the pressure angle that we're using, and that's 20 degrees times the diameter of the pitch circle, so times the pitch circle diameter. And so it's basically the cosine of 20 is something like 90, it's like 0.97 or something. So it ends up it's a little bit smaller than the pitch circle. So if this pitch circle is 40, the base circle is going to be something like it's going to be something like 37 or something. And so we're going to use that. We're going to use the base circle in order to draw the little sides. And so we're going to draw the little sides on the base circle, and then we're just going to draw a line straight down from the base circle to the dedendum circle. And oftentimes you'll see that's where you see these little straight lines when you look at a gear closely. They'll be curved at the top, and the straight line starts. The straight line is starting at where the base circle basically starts, and it goes all the way down to the dedendum circle. And sometimes it won't be a straight line, but they'll curve it like that. So you can curve it in your gear design, and that's just to get more, so your gear is sturdier basically, because if you curve it a little bit, it has more material there to hold. So this is a little bit sloppy, but I'm going to I'll jump on Inventor and kind of show you this process and actually how to build one. And I think if you're not understanding it quite yet, you'll get it then. So let's move to Inventor. Alright, so we're building our spur gear, and so for this spur gear I chose to use the diameter of 40 millimeters and 18 teeth. And so remember, when you're designing your spur gear, you can start with the smaller one, and start first with the smaller one, and that's what we're doing here, and then move to the bigger one. And so we're going to start with the smaller one, and then you can move to the bigger one. But the only thing you need to keep in mind is that you need to make sure the proportion of diameter to teeth stays the same. So if we're using 40 millimeters for the diameter of the smaller one, and 18 teeth, and then for example 80 millimeters for a larger one, then we need to use twice as many teeth, so 36 teeth. And that ratio is just called the module. So that's the diameter divided by the number of teeth. So it's as simple as that. We'll go ahead and start. So I'm going to start by just drawing a circle, and I'm going to start by drawing the pitch circle. And remember, that's the kind of imagined circle, and it's where we it's basically the imagined circle, and so that's going to be 40 millimeters. And then we're going to draw the dedendum circle, and to do that, remember the equation that we had before, or sorry, we're going to do first we're going to start with the addendum circle, and that's just the module. So let's go ahead and find the module for this. And remember, the modules is just the diameter divided by the number of teeth. So let me just real quick. So that's just going to be 40 divided by 18. And what do we get? We get this number, 22.2222. So that's our module, and that's going to be a helpful number. So we're going to go ahead and just make a line here, and it's going to be just 2.22222. So that's that, and I'm going to make a circle that connects to there. That's the addendum circle on the outside. And then we want to do the dedendum circle, and so that's just going to be the line that comes in here. And what is the dedendum circle? Remember what I said before in the equation? The dedendum is just the module times 1.25. So it's this times 1.25. It's actually 2.77, except it's smaller, not further out. So we'll go in, we'll draw this line in at 2.2 whatever I copied there, 2.777, and then we'll do the circle to there. And that's going to be the dedendum circle. Alright, and then we need to draw the base circle. And the base circle is what we use to draw the involute curve on. And so in order to get the base circle, remember what I talked about where we use the angle, the angle of 20 degrees. And we could use a different angle, but this is the one we want because that's the line of the tack, or I think what's called the pressure angle. And so the equation for the base circle is just the pitch diameter times the cosine of the degrees. And so the cosine, we'll just do cosine of 20. What is cosine of 20? We need degrees though. It looks like radians. So it's this number, and then we're just going to do times 40. So this is the diameter of the base circle, which is the important circle that we're using for to draw our inlet. So is that right? 37.585. All right, cool. And so now this is our base circle, and you can see it's a little, this is our base circle, and you can see it's a little bit bigger than the dedendum, smaller than the pitch circle, and definitely smaller than the addendum circle. And so how do we draw the involute curve? So remember what I talked about before about the involute curve, which is basically if you had a piece of string coming, you can imagine a piece of string raveled around your gear and just taking it and rolling it out or bringing it out. That would be the involute curve. And if you have a program like Inventor, we can cheat a little bit, which is nice, and we can actually use this equation curve, and we can write an equation for it. And so the equation for it, and if you're just doing this on paper, you could actually wrap a string around a circle and put a pencil on the end of the string and just peel it off, basically, and that would draw your involute curve. And that's basically what we're going to do, but we're just going to do it with a programmatic equation. And so this is our equation. It's just the radius. Well, it's just this. So x is this and y is this, and we can put this in Inventor, except we need to get our radius. So it's 37.58. It's that, but we need to divide that by 2, really, because it's the radius, not the diameter. So this number is our radius. So do this, and there's a couple quirks that, and you can actually see there's a couple quirks that Inventor has. So if you're working in Inventor, you need to change this because it automatically goes to degrees, so you need to click the show units and change here to radians rather than degrees. That was kind of annoying at first. So you can see the Tmin and the Tmax, and I'll just show you what it looks like. So you can see this circle growing and growing as I make this bigger. But that is the involute curve relative to that circle. So I don't need it that big. I just need it big enough so it goes past there. It's plenty big. Here's another quirk on Inventor. You can't use 0 for some reason. If you put the Tmin as 0.001, it works fine. Otherwise, the extrude will not work. It's a bit annoying. So there we go. There's our involute curve, and you can see it's coming off of the base circle there. I'm going to go ahead and draw a line from center point right up to that. And so the other thing that, and this is probably the tricky part, is we need to figure out, let me just clean this up a little bit. I'm just going to trim the end of there. We need to figure out, so this is the right side of the tooth. And then there's going to be some top of the tooth and then some left side of the tooth. But what we don't know is, where the left side of the tooth starts. And so remember before when I told you, and let me see, when I said that the tooth width is the same. Let me see if I can illustrate this. So it's a little bit hard because this is small, but so you can see the tooth width. Let me put this here. If you view the tooth width as from here to here on the tooth, that is the same as the tooth. I guess you call that the cavity or the non-width. So it's the same, the distance of the tooth width should be the same as the non-width right next to it. But only at, let me make this small again, but only at the pitch circle. So in other words, from this point to this point to some point over here. And so since we have 18 teeth, we can just do a simple calculation. We know that it's the same lengths. So that means each tooth is going to have assigned to it, let's see, 10 degrees, because it's 10 degrees for a tooth, 10 degrees for a non-tooth, and we have 18 of those. So, dun, 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 and you can, that calculation shouldn't be too hard to do. So what I'm gonna do is, so for a full tooth, if we have 10 degrees per tooth, then for and the way I'm doing is that it's I'm doing 360, which is the degrees in a circle, divided by 36, which is twice the tooth number. Because really, if you think about it, there's 18 teeth poking out, but there's also 18 teeth poking in. So there's really, in a way, there's not 18 teeth poking in. There's 18 non-teeth is the way I think about it. So you have a total of 36 teeth. So we're just dividing 360 divided by 36, and we're getting 10 degrees per tooth. And now, since we're trying to find the middle of the tooth, we don't want to use all 10 degrees. We just want to use 5 degrees. So what we're going to do is we're going to get 5 degrees, but first we need to draw. We're going to draw this line first, and then we're going to draw another line that's 5 degrees away from it. But we need to do this. We need to dimension this. I noticed this before, so that this line doesn't move. So I'll just keep that. Draw another line. And so this is the line that we draw that we're going to make 5 degrees. First I'm just going to draw it, and then we're going to dimension it to 5 degrees relative to this line. So 5 degrees, boom. And so there's our right side of this tooth. And so we want to mirror. We're just going to mirror it. Mirror line, we'll use the center line and apply it, and then you can see the left side of our tooth. So now our tooth is starting to form. And then I'm going to go ahead and draw a line down to here. Okay, cool. And then so you can see kind of the profile of our tooth is formed. And I'm not very good with Inventor, so I don't know the best way to extrude this without just trimming all this stuff. So that's what I did. I just kind of trim all this junk that is not the actual tooth that we need. Wait, okay, yeah, that's all right. Literally just trimming everything. I don't know. Oh wait, I don't want to trim. That is the bottom of our tooth, so I don't want to trim that, but I do want to trim this. Wait, so I don't want to trim this, okay, because that's the bottom of our tooth. So that's all okay to trim. Doesn't like that, huh? Delete that. Oops. Okay, yeah. Delete that. I'll even trim this outer thing. I'm not sure if I have to. I think that'll probably do it. The one thing I noticed before is, remember how I had to put that .001 in? Sometimes I think this line it doesn't like, so I'm just going to draw, make sure from there to there. So this curve, when I started it with the equation, was actually a .001, not 0, so it doesn't quite get it right. So I think this profile should work, but let me go ahead and I'm just going to trim this as well. For those who know how to use Inventor better than me, feel free to tell me how to do that right. So, yep, I'm going to extrude it. And real quick, here's another rule that's kind of, I think, another rule of thumb. When you're making, as far as your depth of your gear, the width, like, I guess the depth, how deep the gear is, rule of thumb is more than 8 times the module and less than 16 times the module. I'm pretty sure that's right. Correct. If anyone knows more, correct me if I'm wrong. It seems kind of thick to me, but we'll go with it. So 8 times the module. The module's 2.22. It's actually more than 16, but I'm just going to do 16. Before I printed it at only 10 millimeters, and they seem to work all right. So there, then we have one gear. And now all we have to do is use the, I don't know what you call it, the go-around tool. That's what I call it. And select an axis of rotation. I think looks like it's the Y. And remember, we have 18 gears. And so there are our gears coming in. All right, cool. So I'm just going to fill this body in with a circle here. And 35 point. Do we remember the 34.56? That seems right. That was the diameter of the dedendum circle, so that seems good there. I'm going to finish this, just going to extrude it 16 inches. There we go. And then, so that's, yep, there's our gear. The other thing you can do here is you can kind of see, you can actually visually see where the base circle is now. That's where the base circle is starting, and then this is where the dedendum circle is starting. And so we have a decent amount of clearance here. And if you want, you can fillet these two edges. Just make sure the fillet doesn't go up past where the other gear would connect. So that's how you make a gear, and we have it. And I guess the other thing you can do is put a nice little circle here. I'm just going to make that 5 millimeters. Going to extrude it. Let me go the other way. Cool. And so you have it. So there's our gear, and you can go ahead and print it out or do whatever you need to do with it. And remember, the other thing is when you're making, this is the smaller gear, so when you're making the bigger gear, just make sure you have the same ratio, and you just walk through the exact same process, and they'll fit, and those two gears will fit together and be able to spin together. Remember, the module is what needs to be the same on both gears. So cool. Let me know if you have any questions, and thanks for watching. Bye for now.